be starting a new learning target on mole conversions. We also more often use the term dimensional analysis. And the great thing about this learning target is that you've already seen dimensional analysis when we were working on conversions back in our unit on metric measurements. All right, so if you remember back to conversions, one of the problems might have asked you to convert from 5 kilometers to meters, right? And if you remember how to set that up, we had 5 kilometers on top, we set up our skeleton, and then we filled in our conversion factor, all right? Our units on top and on bottom canceled out, and we ended up with 5,000 meters, all right? So that's how we did our conversions. Dimensional analysis looks very similar, and it's using the same concept, all right? We're just going to be looking at dimensional analysis in terms of the mole, because remember, we're now doing our unit on moles. So our steps for doing this are the same as they were when we were doing conversions. We're going to start with a given. We're going to make a skeleton, right? And if you look at the example over there, that much has been done for you. We have our given and a skeleton. Once we have that, we're going to put our given unit on the bottom, so whatever the given unit is. We'll put the wanted unit on top, and that's the unit that we're trying to convert into, or that we're trying to get our final answer into. Then we will fill in numbers from the equivalency statement. The equivalency statement when we did conversions was our conversion factor. 1,000 meters is equal to 1 kilometer. So that was our equivalency statement. Then at the very end, we check our answer for sig figs, units, and then box our answer. So let's take a look from an everyday example we might see. All right, so our example here is how many dozens of cookies should you make for a party of 60 people? All right, if every person gets 1 cookie, that means we need 60 cookies. So 60 cookies is our given. All right, 60 cookies is our given. We set up our skeleton. Step 3 over there, our given unit goes on bottom. We're given cookies, so cookies goes on bottom. Our wanted unit goes on top. All right, we're trying to figure out how many dozens, so dozen goes on top. Then we fill in our numbers. Well, what's our equivalency statement? We know that 12 cookies equals 1 dozen. All right, so 1 dozen is equal to 12 cookies. Now we can solve. 60 cookies times 1, 60. Divided by 12 gives us 5. And what's our unit? Remember that units on top and bottom cross out. So we're left with dozen. So we would need to make 5 dozen cookies. Okay, so that's an everyday example we might see. Let's take a look at this from a more chemistry point of view. All right, so looking at moles. Now, remember that our equivalency statement for conversion factors is the conversion factor. 1,000 meters is equal to 1 meter, or 1 kilometer. For moles, our equivalency statement is this. 1 mole is equal to Avogadro's number. Remember, this is Avogadro's number in particles. And those particles can either be atoms, molecules, formula units, or a couple others that we'll see eventually. This is also equal to the molar mass in grams per mole, right? We saw this last video, our molar mass in grams per mole. It's also equal to 22.4 liters of a gas, only a gas, not a solid, not a liquid, and only when it's at STP. And what we mean by STP is standard temperature and pressure, right? Now, this isn't incredibly important right now. We will see it more. What's important is that this is only true if a gas is at STP. If it does not say that the gas is at STP, then the volume is not 22.4 liters. It's only at STP. What our standard temperature and pressure is, just to give you an idea, it's a temperature of 0 degrees Celsius and a pressure of 1 atmosphere. We'll see that in a couple units. All right, now, this equivalency statement is integral to everything that we're doing, all right? So I've laid it out here You'll hear some people call this mole island or mole highway, right? But what this is it's laying out how to convert from one to the other. So kind of like converting from cookies to dozens of cookies. Here we can convert from volume of a gas to moles, moles to particles, moles to mass, right? We can convert between all four of these. What you notice is that in the middle of this is 1 mole, all right? 1 mole is the center of our world right now. No matter what we're converting to or from, we're going to use 1 mole, right? So everything revolves around this mole. The 22.4 liters of a gas is equal to 1 mole. 1 mole is also equal to 6.02 times 10 to the 23rd particles. 1 mole is also equal to X number of grams. X grams, right? Or some mass. Here's where we're going to use the molar mass. So all of these are equal to each other, okay? Now, let's take a look at an example. We're going to do the same thing we did for our previous example of cookies and dozens, right? But actually with chemistry, okay? So, we have our given. First of all, how many moles are in 25.5 grams of Ag, silver? All right? We have our given, 25.5 grams of Ag. We have our skeleton. So, step 3 is put the given unit on bottom. Grams of Ag goes on bottom. Our wanted unit on top. We're trying to find moles. So, moles of Ag goes on top. Now we need to fill in the numbers. We're going to use that equivalency statement, all right? Whether you're using the one up here or what you see down here, they're both the same. So, how many moles of Ag? Look here. 1 mole is at the center of all of it. So 1 mole is equal to how many grams of silver, right? Now, this is where we're using the molar mass, okay? So we're going to look at the periodic table. We're going to find silver. And we're going to see that the molar mass of silver is 107.87 grams per mole. 107.87 grams per 1 mole, right? Our units on top and bottom cross off. Grams of Ag is gone. And we divide 25.5 divided by 107.87 grams. We get 0.2364 moles of Ag, and we need to make sure that our sig figs are right? We have the right unit, moles of Ag. Our sig figs have to be right. 3 sig figs here, 5 sig figs here. Which one is less? 3 sig figs is less. So this needs to be 0.236 moles of Ag, and that's in correct significant figures, right? Now, we're going to take a look at 2 other examples. One step, which we just did, but we're going to take one more look at it, and 2-step dimensional analysis using moles. All right, so our single step. This is when moles is the wanted or the given unit. So either we're converting from moles or we're converting to moles, okay? So here, what volume in liters does 5.25 moles of CO2 occupy at STP? Now, notice a couple things. Moles is part of the problem. This is going to be a single-step problem. Notice also that we have a gas, carbon dioxide, at STP, right? So, for our equivalency factor, we're going to be using that 22.4 liters of a gas at STP is equal to 1 mole. This is our equivalency statement, okay? So, we have our given, 5.25 moles of carbon dioxide. Do you have to write moles? Yes. Do you have to write carbon dioxide? Yes. You have to write both of them. We have our skeleton set up. So my given unit, moles of CO2, goes on bottom. My wanted unit, volume in liters. Liters of CO2 goes on top. Do you have to write liters? Yes. Do Do you have to write CO2? Yes. Okay. Now I need to fill in from my equivalency statement my numbers. 22.4 liters of a gas equals 1 mole of that gas. Now, with all of these that we're doing, your number of moles will always be 1. Okay? So, our unit on top and on bottom crosses out, and we multiply. 5.25 times 22.4 gives us 117.6. My unit that's left is liters of CO2. But I need to look for sig figs. I have 3 sig figs here. All right, 3 sig figs there, so we need 3 sig figs in our answer. 118 liters of CO2. Okay? Now, the last example that I have here. What if moles is not part of the problem? What if it's not a given and it's not the wanted unit? All right? Now we're going to have to do a 2-step problem. Okay? So double step, moles is not the wanted or the given. Now, our rule is, remember, everything, all of our equivalency statement revolves around the mole. Okay? There's a reason that mole is in the middle. We always go to moles first. If moles is not the wanted or the given, doesn't matter. Go to moles first. Okay? This will make what we do in subsequent units a lot easier. So, how many atoms are in 55.2 grams of LiCl2? Okay? My given on top, my skeleton is set up. Now I have to put my given unit on bottom. Grams of LiCl2. Now, even though the wanted unit is atoms, you have to go to moles first. That means moles of LiCl2 is the unit that's going on top. Okay? So, fill in the equivalency statement. How many moles of LiCl2 is equal to how many grams? Well, we know from the equivalency statement, moles is always 1. 1 mole of LiCl2 is equal to how many grams? Okay, if you remember, when we're using grams, we're going to look at the molar mass. Conveniently, I've calculated the molar mass over here for us already. The molar mass of LiCl2, we have 1 lithium at 6.94 grams per mole, 2 chlorines at 35.45 grams per mole each, for a total of 77.84 grams per mole. If you're having trouble calculating this, you need to go back to the 6A video, okay, and get more practice. So my molar mass is 77.84 grams per mole. 77.84 grams per 1 mole, okay? Now, what unit crosses off? I have grams on top and grams on bottom. Now I'm left with moles. Is that my final unit that I want? No, I want atoms. So we're going to take this 1 step further, okay? Repeat the steps. Now, what unit do I have on top? Moles of LiCl2. So, moles of LiCl2 have to go on bottom. What is my wanted unit? Atoms. So, atoms of Cl2, LiCl2, go on top. From our equivalency statement, how many moles is equal to how many atoms of LiCl2? Our moles, number of moles, is always 1. How many atoms of LiCl2? Now, if you remember and look back at your equivalency statement, the 1 mole is equal to Avogadro's number in particles, whether the particles are atoms, molecules, or formula units. Okay? So, 6.02 times 10 to the 23rd atoms of LiCl2. My moles cross off, and I'm left with atoms. Okay? So my final unit is atoms of LiCl2, which is good. Multiply 55.2 times 6.02 times 10 to the 23rd. Divide by 77.84, and you get 4.27 times 10 to the 23rd. Atoms of LIC.